we am here to talk about machine learning and accuracy and how you can improve your accuracy in machine learning. So thank you for the introduction. The Center of Excellence in Artificial Intelligence of Fujitsu is based in the École Polytechnique, especially in the startup incubator. Most of the rest, you've said it. Just a few words, because I'm pretty sure that if I get too far from the microphone, you won't hear me, but just a few words about machine learning. I'm pretty sure that every one of you have heard about it, but I want to say a few words about it. For me, machine learning is the ability to learn from past experiments, okay? And it's really important because it's not programmed. You don't have to hire tons of developers to build an expert system, okay? And that's the major advantage of machine learning regarding what you can do in expert system in symbolic artificial intelligence. This being said, machine learning has a major drawback. It's good at interpolation, but not extrapolation. Extrapolation is you're showing a 2-year-old 2 cats, he knows what a cat is. But if you want to do the same thing with machine learning, you will need thousands, hundreds of thousands of images of cats and dogs to build a model of what a cat and a dog is. And if you show to this model a cow, it might say you, in best case, that it's a dog, in the worst case, that it's a cat, and maybe, just maybe, it will say, I don't know. That's the main difference between interpolation. You know you've been learning on data, and when you apply what you've learned on data you don't know, if the data you don't know are too far from the data you've learned on, you will lose accuracy. For example, if you build a self-driving car, let's say, in a nice, quiet, calm city, it won't prepare you for the next phase. It won't prepare you for the rond-point des Champs-Élysées that we all come to love, but where people can be pretty mean. And it won't, this is pretty sure, prepare you for the roads of India. Okay, this being said, even with those major limitations, there is a huge hype around machine learning. It was Accenture saying that 85% of executives plan to invest in AI-related projects, and that's maybe, I'll tell you something like 300% growth in the AI-related industry. Why? Why machine learning have managed to achieve such results? First of all, the price of storage. In 1980, 1 gigabyte of storage was $500,000, and today it's 3 cents a gigabyte. This explains, only this explains why machine learning could only prove its best results today, okay, and in the past 5 years. Because in its infancy, in the 90s, all machine learning techniques already existed. But they failed to deliver value because there wasn't just enough data to learn on. In the 90s, most web servers don't store their logs beside 24 hours. They will lost it because they don't have space to store them. The other thing is, in machine learning, you now have a huge technical ecosystem that will provide capabilities to compute those data. This means like with technology with Hadoop, which is more than 10 years old now, and Spark, more recent, or all the technologies you can find in this ecosystem, it has been cheaper and cheaper to store and to process data. One more thing, GPUs. In the last 5 years, there has been a tremendous accomplishment for neural networks, and this explains vastly thanks to GPUs, because GPUs to process neural networks are something like 8 times even more powerful than CPUs. Okay, so thanks to all this, we now can process vast amounts of data, and machine learning algorithms are able to build real good models, okay? And those models, you can find it in 2 major techniques: reinforcement learning and supervised learning. Reinforcement learning is you simulate your environment. For example, you can learn how to play Go with reinforcement learning. You simulate the game of Go, and you make your computer play against himself millions of games. I think that the last one is something like 60 million games per second, and he learned to master Go in only 3 days. That's raw compute power used to learn how to play a game. But you can also use reinforcement learning to teach robots how to work. You can simulate the act of working in a pure virtual environment, make the simulation work and work and work and work hundreds of thousands of kilometers. It will fall, it will fall, it will fall, but in the end, it will learn how to work in a pretty secure way. And then you will be able to use this model in an actual real robot that will be able to work stairs and things like that, everything that has been included in the simulator. But there is always the same drawback. It's interpolation versus extrapolation. If it hasn't been seen in the simulator, it won't be able to face it in reality. The next one, the one that I think is the most that have been there for a really long time is supervised learning. Machine learning is learning for experiment, and in case of supervised learning, it's learning from tagged historical data. Let's say that you want to learn fraud, okay, in banking. You need a huge training data set with bank transaction, and you need to tag them one by one, fraud, not fraud, fraud, not fraud. This is supervised learning. You will train a statistical data set, a statistical model that will learn the patterns of this is a fraud, this is not a fraud. Okay, how does it work? Most machine learning project goes always the same way. You collect data. It can be data from simulation, it can be video, it can be images, it can be speech, it can be raw text, it can be, in some cases, when you're lucky, structured data. And you apply data engineering. Then data engineering comes in to present the most value of your data to your algorithm. Then you do a learning, you generate a model. This model is a synthetic view of what is in your data in order to accomplish this task. You test on unseen data, and you get accuracy. This accuracy, and I'm not talking about, not only about technical KPIs like lift or walk or area under the curve. I'm talking about business metrics, because at the end of the day, this model will be deployed in production to take decisions, to make decisions. And those decisions will decide if you win money or if you save money. Okay? So at the end of the day, the best KPI to learn to see the accuracy of your model are business metrics. How can you improve on this process? First, the one that comes often is improving the algorithm itself. Let's take an example. I don't know if you are aware of this NIST, but NIST is both a challenge and a data set. As a data set, it's composed of 60,000 images of unwritten digits. Okay? Back in 1998, a basic linear classifier made 12% error rate. Okay? And in 2012, a committee of 35 convolutional neural networks took this error rate down to 0.23%, doing better than a human being. It took 14 years of open research to go from 12% error rate to 0.23% with the same data set. Another example I really like, because it has tremendous impact on the research field, is ImageNet. ImageNet today is more than 40 million tagged images. And for more than 1 million of them, you also have bounding box saying, this is a bird, this is a frog, this is a kid, this is a chair. The goal of the challenge is object recognition. Back in 2010, without neural networks, the error rate of the first contender was 25%. In 2015, it was 5%. And in the process, the first convolutional neural network was starting in 2012 and reached 16% of accuracy. Today, the error rate is below 3%, better than a human being on the task, and the challenge has been closed. But still, it took 7 years of open research to go from something that is not production ready to something that is better than a human being. Improving the algorithm can prove very difficult. You can hire top AI researcher, you can buy the best algorithm there is in the field to your business case. It's really tough. Next thing to improve this process is data engineering. And data engineering is two main things. First, data cleansing. Your data can be corrupted, inconsistent, dirty, irrelevant, inaccurate. All this represent noise in which will prevent your models to capture all the essence of your data. Removing this is vital if you want to optimize your process. The less noise you have in your data, the better your accuracy will be. The next one is feature engineering. Feature engineering is how you add business insight inside your data. Let's take an example. This is a 10-digit numbers, yeah? No, in fact, in a database, this is a date. This is a date using the Unix time format. In fact, this is a number of seconds elapsed from the 1st of January 1970. If you feed it like this to an algorithm, will you get insights? Yeah, maybe, if you're lucky. What's important in this date is that it was, in fact, a Monday morning. It was in September. It was in 2017. In fact, it was the 25th of September, a Monday morning, at 10:30 a.m. But most importantly, if you want to sell me something, you better know that it was my birthday. Feature engineering is adding insights to your data, business insights. How do you value your data? If you stay with the basic encode format in which it's stored in your database, you will lose insights. Third thing, more data, of course. The more data you get, and there is a reason why data is a new whole is a thing you've been hearing for the last 10 years, is because more data equals more information equals more accuracy, and in the end, it's more money. Those data can be of many forms. You can have demographic data, behavioral data, and by the way, if I want to sell you something, it's much more important that I know that you are buying action movies, that you've been in holidays in Spain, things like that, than knowing that you are a 41-year-old male that lives in Paris. Behavioral data beats demographic data every chance it gets. You can also put some geographical data, some weather data. 30% of businesses are weather dependent. You might think that your business is not weather dependent, but you should try. Try to insert weather information in your dataset and see and check. If you gain accuracy, in fact, somewhere, you are weather dependent. And of course, last but not least, the huge trove of information present in open data. It might be needing some data cleansing, of course. It might be needing data engineering, but it represents a huge trove of data in which you can get more insight for your business problems. Okay, so you have improved your algorithm, you've improved the data engineering, and you've gotten many, many data. Yeah, but the behavior of your customer is changing every day, every hour, every minute. And with techniques that are good at interpolation, not extrapolation, how can you adapt to this change? Well, there's no highway. you need to refresh your models as fast as possible. This means that you need a huge investment in infrastructure in order to collect data from everywhere as fast as possible. You need to use those data to make better decisions, to put back those models in production as fast as possible, and then collect the results of those decisions to retrain your models. Like this, you build a virtuous cycle of continuous accuracy improvement. Yes, but machine learning will give you great insight. There is lots of information there to be gained, and it will improve your business. But machine learning isn't only as good as your business strategy. Example, you want to sell products online. And you want, for this, you say, okay, I'm going to buy a lot of displays, and I want to optimize the click probability on those displays. You will do a lot of profiling, gather information on the website that are most interesting for you, etc. And you will begin to optimize your models on the probability of clicking on your ads. Yes. But what you're really, in fact, doing is building a huge honeypot for bots. Because today, more than 50% of internet traffic come from bots. And bot clicks, they click a lot. So what you really should be doing is not improving the probability of clicks. What you really should be doing is improving the probability of selling a product. It's a little bit more difficult, yes. You have less data on that than you have on the clicks that you received. But while doing so, you will naturally build models that will avoid bots. Because bots clicks, yes, but they don't buy. So let's wrap up. I don't know how long I have more, but great. Okay, you have beaten the algorithm complexity. Either you have a top-notch AI researcher, or you have bought the best models you can find out there. Okay, great. Your data are cleaner than ever and full of business insights. You have gathered all the data there is, and you have put together a huge infrastructure that is doing all this in real time. And finally, your models are refreshed as fast as possible. You may be even using incremental learning to update your model in real time. And finally, your business strategy maximizes your business insights and vice versa, of course. So now, what you can do to improve your accuracy? Well, you can do it again. This is why it's really an endless quest. It will never end. You will always have new algorithms that will bring a bit more accuracy. You will always find more data, and you will always find new ways to extract insights from those data. Thank you.
Thanks, Thierry. So I will jump directly to one question I had in mind when I was listening to your presentation. Is you're talking about accuracy, and in your presentation, it's accuracy compared to results that you know. For example, you know that it's a cat, you know this picture, and so on. So you can compare the result of the algorithm based on non-results. I mean, you know the results, or you know what should be the results. But there is also a lot of discussions around accuracy of algorithm where you don't know necessarily the result. I mean, if I take, for example, the pictures and I apply it to health, X-ray. You don't necessarily know the results, and still you're going to ask the algorithm to predict, and at the end you don't know if it's accurate or not. So here accuracy is even more complicated. What's your feeling on that?
I think that what you're referring is unsupervised learning, when you don't know what you're looking at, and you try to find hidden pattern in it. And unsupervised learning has been a tremendous field of research recently, but it's still in a really early stage. The main result that we have seen is in reinforcement learning and supervised learning. There is many things that you can do that we hope to achieve with unsupervised learning, but it's still in infancy for now. For example, if you're talking about X-rays, I know that what you can do is crossing information with the patient documents and the doctor's diagnosis. You will try to extract as much information from often those that are text-related, and then you will find a way to tag all those images in order to come back to a problem that is much more easier, which is supervised learning.
Okay. Any question over there? Yes.
Hi, thanks for the good talk. My question is, are there things that AI can learn or get out of the incorrect or bad data? Like, are there things that you can detect or understand about the nature of incorrect or things that would get thrown out in the cleaning process?
Yeah. In fact, yeah. For example, you can use a machine learning algorithm to, let's say that you have, in your data set, you have few columns that are really sparse. You have lots of missing value, and you don't know how to fill those missing value. What you can do is training a model on the value you have to find the patterns inside those data, and then apply it to all the new values that you have to try at least to have a probability of, let's say an example, you don't know the sex of the people you're dealing with for 80% of your data set. You do a model on the 20%. This will give you the probability of being a male or female, and then you apply it to the last 80%. That technique helps you. For me, it's entering feature engineering and, of course, data cleaning. It will help you get insights, but it can be dangerous, especially if you do it a lot for lots of variables. So yes, if the variable you have has lots of missing value and potentially lots of information, that's a good technique. But don't repeat it too much, because your data set will only be based on prediction of predictions. And you will lose a lot of accuracy when you apply your model in real world.
Any other question from the audience? Don't be shy. There's one over there. Alex.
Hello, thank you for your presentation.
Thank you.
I'd like to ask you a question, because we saw a lot of improvements in AI and data collection and treatment.
Yeah.
But as you mentioned, business strategy, do you have the feeling business strategies who are using big data are slowly progressing comparing to all the technological advances which are done?
Yes, I do. Yes, I do, of course. Machine learning is used more and more to gain business insight. That's a basic subject of my presentation. But I think that's the biggest risk now is using this tool without the proper skills. As I said in my last example, your data on your business objective can be really biased, and this the algorithm won't tell you. In fact, if your data are biased, the algorithm will tell you it is super confident that walking over this bridge is a good idea, and if you apply this model in for real problem, it will cost you a lot. So the strategy you can use around that is fix objectives that are really business related and A/B test. This way you can avoid to put models in production that won't deliver value but have been showing quite precision, good accuracy, but in only technical KPIs.
Just as question, Thierry, coming back to Fujitsu and what you're doing. So what's the hottest subject you're working on right now? What's the thing you want to do and
From what I've seen so far, and I've been there a month and a half, there is a huge trend in the video analytics. In fact, being able to process videos is something really important because video is, in fact, everywhere. Cities, for example, have been investing for CCTV for a long time, but they don't use it. And there is a lot of insights you can gain from videos, and processing those videos in real time can gain you, improve your business in a dramatic way. And after of course, there is all the new techniques around image processing. And if you are able to process a huge amount of data, you will gain, no matter what, a huge business impact.
Okay, thanks a lot. Thank you, Thierry.